And I
Sorry
almost
about
forgot.
that.
Thank you, sir.
Hope you're on medication.
Yes, I am. Thank you, sir.
So let's just move to today class won't take long anyways. So let's just hold up for like okay, Labibat. Welcome Labibat. So just hold on for like this is 6:11. 3 minutes at most. 3 minutes and get started.
All
Hi
right, sir.
Labibat. How you doing?
I'm fine, sir.
Yeah, you're welcome. It's been long I saw you. What's happening?
Sorry, sir. I've been having exam in school. Preparation for exam.
Oh, exams. All right. How is it going now? How's the exam going?
It has been good so far. Alhamdulillah.
What course are you doing in school?
Medicine.
Oh, medicine. Wow, I can imagine. So how do you manage medicine with tech?
Sorry, sir. I can't hear you, sir.
Yeah, how do you manage medicine and tech? I could imagine that medicine sometimes, especially in school, could be demanding. So how do you manage both?
Yes, sir. I just look for probably a free time. Any free time I'm able to get, I'll just like quickly do
Mm,
some things. Probably 30 minutes, 1 hour.
okay. Mm. Oh, that's fine. That's fine. It's good to know that at least you're putting your best for the tech side as well. Well done. But have you been doing your
Thank
assignments,
you, sir.
taking the courses as well, or you kept them on pause during exams?
Yes, sir.
Oh, no problem. Okay. And seeing more people are turning up. That's good. Hi, Deji. It's been a long time. Welcome. Hello, Deji. Okay. You're welcome to the club. Okay, so let's get started. But before I continue, the courses on the platform, has anyone been able to complete it? All courses, including the few projects that are on the track, who have been able to complete it? Okay, since nobody. Okay, so who is like 80% done? Is anybody 80% done? Hmm.
Mr. Paul,
Like,
sorry, I want to say something. Hello.
okay, okay. Oh,
Okay. So I went for
that's
NYC
something to do.
orientation camp like for 3 weeks. I think it was like 2 weeks ago. I just came back from camp. So some of these courses, I couldn't go with my laptop because you're not allowed to carry like electronic devices. So some of those courses that I missed,
Oh, yeah.
I wanted them reassigned to me. And I said it on Discord that I needed them to be reassigned. I think there were like 3 or 4 courses, so I could continue with them.
Okay.
Well, I've been doing the
Hmm.
ones that are on my own, but those ones I want them reassigned to me so I can complete the assignments. So yeah, that's the challenge I'm
Okay.
having right now. Thank you.
Um, okay, okay. We'll see how we can look into that. Maybe you can just follow up this on Discord. Let me open my Discord. Anyways, how is NYC going? I guess you're back.
Oh yes, yes, I'm back. It's been fine. Thank you so much. Thank you.
Uh,
I've been, struggling to catch up, but yeah, I'm back now, and I'll make sure I finish this. Thank you so much.
so what's your progress like on the entire track? What's the percentage?
Okay. I think I'm like 60%, 65% in, but it's something that sometimes I can do like 3, 4 courses like in the space of 2, 3 days. So it's not, yeah, I
Hmm,
can catch up.
okay, that's fine. That's good. Hi, Hikma. How much progress do you have on the track so far?
Sir, I think around 50, 60. I've also been busy with camp stuff and NYSC.
Hmm, hmm, I see. Since everyone are now serving our dear country.
Yes, sir.
So how is camp your own and how's it going?
It's going fine, sir. Thank you.
Uh, Labibat, I think she's having network issues. Hi, Emmanuel. You're late to the class today. Hmm. All right. Deji, can you just drop a message on the Discord group now? Let me see your name pop up.
Thank you.
All right. Hello, Emmanuel. Since your network is having some issues, I believe it's stable now. How you doing, Emmanuel?
I don't know. I'm okay. I think that I've been kicked out because I couldn't meet up with the what's it called? I couldn't complete some of the classes on data camp, so my access was revoked and
Hmm.
all of that. But yeah, I'm fine.
Hmm. So,
I'm good.
okay.
Yeah.
Oh, wow. Okay. But what's the reason now? Why didn't you
It
follow up with the
was it
course?
was just work. It was work. So work was a larger part of why I couldn't finish up with the stuff. So I work remotely, and sometimes I'm finishing work later than expected, even working weekends sometimes. So
Oh,
I
oh,
couldn't like really put as much in, dedicate as much time as I wanted to. So yeah.
right. I see. Wow. That means your job is really demanding. So,
Yes, yes, yes. I even thought I was gonna be able to like get time off or something to like just go through each and every one of those things, but it didn't work the
mm,
way I expected. So yeah.
okay. Now, this is just it's very little advice. This is my 2 cents, and I have to share concerning that because I think recently I even made that mistake. If you have a job, fine, it might look like you don't have the time most times, but if I tend to, if I should say something along that side, I would actually say just try to balance between your self growth, and the job at the same time. Like give as much priority you're giving to the job, then as much as you're giving to the job, give to yourself because we're talking about you in this situation. Because the courses you're taking on, the stuff you're learning are for your own self, like to get like to be a better version of you in terms of career and the rest. So my advice is just make sure you equal the priority you give to the job and yourself. So even if it's that little 30 minutes, that little 1 hour, you understand, 2 hours, just dedicate it for something to grow yourself because you know, as they say, where you are is a function of what you know and the skills you carry. So I believe you're so far you can put up new skills so that you can change your or upgrade your career and yourself in some other ways. So that's just it for me. Then.
Yeah, that makes sense actually. I mean, it's just you know how some Nigerian employers can be now. So yeah,
Mm.
but yeah, I totally get your point. I mean, I think that I could have done better with my timing, but it just didn't work the way I wanted it to. So yeah, thank you very much.
You're welcome. Hi, Akachi. Welcome to the call. It's been a long time. Hello, Akachi. Since it's not here. All right, let's quickly get something started. Last week, we talked about, we just had Hikma and some other person on the call, just 2 persons, and we touched on deep learning. Okay, so before I go on, apart from Hikma, has anyone um come across deep learning before? There's no problem, Akachi. You're welcome. Good evening. Has anyone touched on deep learning apart from Hikma? Anyone have an idea what deep learning is? Since no one, no from Daisy, no from Emmanuel, no from Akachi. So nobody. Okay, but have you heard of that word before? Have you heard of the word deep learning? All right, that's great. Um, and since we have a few number, I would still love to still want to touch on deep learning because it's apart from the basics of the basics like supervised learning, unsupervised learning, deep learning is another core algorithm or approach or machine learning approach that introduce you into more complex system. All right, let me share my screen. This class needs to take much time. Can you see my screen? Can anyone see my screen? Okay. Okay, Hikma. All right. All right. So, the little survey, the quick survey I could do is, likely no one here has been able to go through deep learning. Okay. That's not the problem. We'll be looking at that now. Let's just to, I was hoping to build more on deep learning today, but let's just go back and quickly see what it refers to. All right. Okay. Deep learning is everywhere, and that's for its facts, and that's factual. It's true. The anyone go far. The ChatGPT we all know today is was built from deep learning. Okay, so that's why it's saying here that it's everywhere. Deep learning is also one of those components built into self-driving car. Uh, Deep learning, an example again is Google Translate. Yes, so these are, you can see these are already popular features or services thanks to deep learning. So that's why I mentioned that alongside supervised learning, unsupervised learning, deep learning is one of the foundation you should very much understand in order to be able to be, in order to familiarize with other complex structures or systems in machine learning and AI. So now the next question is, what is deep learning actually? So deep learning, in terms of hierarchy, deep learning is um, it's under machine learning. Okay, it's under machine learning. Why machine learning is under AI? So the hierarchy of movement is within AI. That's where you have machine learning. Then within machine learning, just like you have supervised learning and other kinds of learning, that's where you can find deep learning. So now deep learning is actually uh, an algorithm. Okay, it's an algorithm that uses layers, that implements layers to learn. Please, can anyone still hear me? This hope I've not been. Okay. What was the last thing I said? Let me be sure my network wasn't breaking up. I'm seeing it's hanging from this end.
You were talking
Hi,
about
Brian. Can you just echo the last thing I said?
we were talking about how deep learning is connected to layer.
Okay. Okay. Yeah. Thank you. All right. Now, like I said earlier, deep learning is a part of machine learning, the subset of machine learning, which is also under which machine learning is itself under artificial intelligence, right? So now, basically, deep learning is using neural networks with many layers to learn. That's how deep learning uh, comes about. It's teaching machines to use neural networks with many layers. Now we'll come back to what neural networks are. Now, there's also one fun fact that deep learning is inspired by how the human brain works. And for a fact, that's how deep learning was actually implemented. It was inspired by how the human brain works. That's why you hear things like neural networks. I don't know if anyone was familiar with their biology, the nervous system. Was anybody familiar with the nervous system? You can just give me thumbs up if you remember one or two stuffs from the nervous system. Okay, since everyone all forgot their biology, that's unfortunate. No one remembers biology. Wow, no one remembers neural network. All right. So in nervous system, um there's this core basic concept for the nervous system build up, and that's what neurons, or in other words, nerve cells. You can also call neurons. Now, if we come to the brain, if we bring it down to the brain is made up of nerve cells, like mostly made up of nerve cells. That's what power the brain. And the brain is a learning machine in itself. It's a learning system. So now, um, scientists and engineers came together and they just look at, they are marveled at how the brain learns. And they say, let's do a system that models how the brain works and or learns specifically. So that's why you're seeing terms like neural network, because a connection of neurons or these nerve cells we talked about earlier gives you a neural network. We'll get to talk about these things more. Now, before I go on, there are three basic layers in deep learning. Three basic layers. First layer, second, the last layer. The first layer is the input layer, where the data goes through, and the hidden layer is where the processing takes place, and the learning and everything. Then output is the final outcome of the data that have been passed through it. And this diagram actually illustrates that you can have as much inner, which is or hidden layers you choose to have. This is in your power. As much hidden layers you want to have. And the more layers you have, the more deeper it is. And that's another concept where they coin the word deep learning from. Because of the internal um, sophisticated layers it tends to have in order to learn about a given subject matter. All right, we talked about this earlier. Deep learning networks is inspired by how the human brain works or learns. Yes, neurons. Now you can see that neurons is what gives uh, birth, if I use that word, birth to neural network. Like a connection of neurons is what gives you a neural network, which you find in this smaller diagram. The bigger diagram was there earlier. So you can see that there is this interconnection between them. Each of these points now you're seeing there are neurons. So this interconnection like this is what you call a neural network. Like one neuron connecting to the other, this connecting to the other, it builds up to become a neural network. So now another basic thing to know about neural networks is these are models. Neural network, deep learning are models. Deep learning gives birth to models that require large amount of data. They produce models that require large amount of data, and this is this is something you should always have at heart. And we'll see the reason why very soon. And this school of thought is suggesting at least 100,000 of these data points. At least 100,000. You can see that's a lot. That's a lot. Yet, this school of thought is saying the risk you should take in. That's amazing. Now, for the sake of this course, we'll be going through deep learning using PyTorch, which is a deep learning framework. But to note, there are a lot of other frameworks out there. There's a lot of them. Apart from PyTorch, there is TensorFlow, and a lot of them actually. Yeah, lots. So you can just look at, depending on the goal you have, at the reach of the framework, you can choose to use anyone. But PyTorch tends to be one of the most popular frameworks and safe to use because they have this active large community. Last time I checked, yes. Although TensorFlow or also they are trying in terms of the limelight, they're trying as well. So now PyTorch was originally developed by Meta AI. It's user friendly, it's intuitive, and it has similarities with NumPy. Yeah, you tend to see the similarities it has in NumPy very soon. I don't want to just keep on going. So far, does anyone have any question or do you understand so far? Please just react, give me some thumbs up if you're following through, or if you want me to go back to a particular explanation. I'm here for. All right, Labibat, please shoot. Yeah, Labibat, you had your hand raised up. This out the mistake. It's all right. So no question. I could only see Ibrahim's thumb. That means no one else understood. All right, Hikma. Hi, Deji. Do you understand? You need more clarification. Okay. Hi, Zainab. You need me to explain something else or something more rather. Hi, Zainab. Okay, since she's not here. All right. Hi, Mahmood. You need clarification somewhere. Please, I will need our actioners so that we can be able to manage time and you know get to the close of the business we have today. All right, let's go on. Let's go on. The majority have spoken. So PyTorch tensors. Now, what are tensors? Tensors are just let's call this the friendly way or recognizable way PyTorch used to interact with your data, like with the initial form of the data you have. Now, tensor is similar to the output of tensors, or yes, the structure of tensors is similar to an array or matrix. It's the building block of neural networks. And like I said earlier, just see it as the base form from which neural networks want this data to be presented to them in order to go on further to do whatever they want to do with the data, which is learning deeply or passing it through the hidden layer we saw earlier. So now to do this practically with codes, we import thoughts. Now this my list is the data you have, for instance. Then what do you need to do? As we just established earlier, that you need to present the data in a tensor format. So that's why you have to convert it to a tensor using this touch to tensor. Like this is PyTorch now. Touch to tensor. You pass in your data, and that's all. You now have the tensor version of your data points. This is the basic and edible form, if I should put it that way. This is the edible form that's the model, the deep learning model wants to have this data. You understand? Now, there are certain attributes after this conversion here, there are certain attributes you can access, which is the shape of this tensor data format and the data type. To see the shape, you can just do dot shape, just run dot shape on the tensor objects. And there you go, you see the size of the data points you have. So in this case, these data points now, we can see here, the size was able to correctly tell us that we have 2 rows and 3 columns on these data points. As you can see here, this data set here, this Highlighting everything. Yeah, this one here now, this data point is, or this data set is of two rows and three columns. Now, tensor data type. The data type tells us the data type of the data points we have. And in this case, correctly, it is integer. Now, tensor operations. There's something you need to know that there are certain operations you can run with tensors. There's a but to that anyway. But firstly, the operations you can carry out are the likes of addition, subtraction, multiplication, and the rest. But before you can be able to safely carry out these operations, they have to be compatible. Now, how do you determine, or how do you know they are compatible? You know they are compatible if their shape, you see the shape you accessed earlier, if the shapes are equal. So if you have two tensors of equal shapes, they are compatible. If the two tensors are of different shapes, they are not compatible. And you can see an example now from the slide here. This tensor on the left, sorry, this compatible shapes section on the left shows you two tensor objects, A and B. And you can see they have the same shape. Both have the shape of what 2:2, right? Yes, we have eight of 2:2. That's two rows, two columns. If you come down to the incompatible shapes section, you can see that object A on the right hand side have 2:2. That's two rows, two columns. But C, object C or tensor C have a different shape, which is what 2:3. Two columns, sorry, two rows and three columns. That means they are not compatible. And if you try to carry out any operation at all, be it addition, subtraction, multiplication, it tends to fail. It will fail. And you can see an error here. To give you an error along this line, that runtime error, the sides are not actually the same in summary. But you can see this one on the left-hand side, which has compatible shapes, tend to run properly. And the addition, subtraction, or whatever operation you want to perform will be carried out effectively. So in this case, I think an addition operation was carried out. You can see when A and B were added together, the first, you can see the first column here, the first row rather, which I highlighted now, is added to the first on tensor B. That's why you're getting 1 plus 2 gives you 3 here. 1 plus 2 gives you 3 here again. Then downwards, 2 plus 3 gives you 5, 2 plus 3 gives you 5. So in summary, they are compatible because they have similar shapes. And this is another multiplication. This is another operation which you can carry out, which is multiplication. You can see they are compatible 2:2, 2:2 for both tensors, and there's no error when the operation was carried out. And this is okay. This is another type of operation. It's called matrix multiplication. Here it involves addition and multiplication at the same time. All right, great. It was explained here. Yes. So you can see how that matrix multiplication is gone about. You can see it's explanatory on the slide here. The first row, and the first column are uplifted, are lifted out separately to carry out the operation for the first part of it. And going further, you see that the second row and the second column, the second row of tensor A and second column of tensor B will go through their own multiplication as well, addition and multiplication. So for the first one, you can see 1 times 2 here. You can see it here, 1 times 2 plus 1 times 3. This first number here on row 1, that is the first object on row 1 to first object on row, yes, the first object on row 1 in this tensor B. I just hope I'm not confusing everyone. That's the two that are lifted up to get these first two multiplications here between this number 1 times 2. Then it's added to the second object on row 1 for A. You get it's now added to the second object, sorry, the first object on tensor B. You can see for row 2, row 2 first object, which is 3. 1 times 3 is equals to 5. But anyways, these are situations would likely not find common during our operations, but just to have an idea on how certain operations are done behind the scenes. So neural networks and layers. But before I go forward, does anyone have any questions so far? Anyone, please indicate with your hand too. I believe we all understand. Okay. Okay, everything is clear then. Neural networks and layers. Now, we talked earlier what neural network is. It's a connection of neurons. It's a connection of neurons that gives birth to the idea of neural networks. But now, there are layers in neural networks in machine learning. And we talked about this earlier, that in summary, the layers in deep learning, rather, I was saying machine learning, specifically deep learning models, are input layer, hidden layers, and output layer. These are just the summary of the layers on how learning is approached in deep learning. So now, the input layer is where the features are passed in. You should be familiar with this word by now. Features in machine learning. This is where you pass in the data points, the features you have on it, and it goes through the hidden layer, does all the processing you need to do, and outputs an end goal, which could be prediction in this case. So there's another thing you need to know that, like I mentioned earlier, this hidden layer can be as sophisticated as you might want them to be. They can be more sophisticated than this, like having so many intertwined hidden layers within them. Okay. Now, neural network. Okay. Now, this is just a linear deep learning model, very basic. This is just very basic. It's very basic. It's a linear model. Because in this case, it's basic in this case because it tends to have less of hidden layers between it. Then, okay, input. All right. Now you can see here that the features you pass in are identified as the input neuron. You should be familiar with the term neurons by now. Okay. So the features you're passing via the deep learning model are, in other words, can be identified as the input neurons, which is this refers to the diagram we've been referencing earlier, which is the input into deep learning system. Now, practically, that's the conversion. Remember the conversion you do to have you do to convert your data point into tensors. So now that tensor in that case, you can just call them the input tensor in that case, you can just call them your input neurons. Yeah, your neurons in this case. And the outputs over time are the classes. Yeah, that if it's a classification task you're trying to solve in that given situation. Now, a linear layer, which is also the hidden layer in this case, it's the next part, right? If you see the sequence of things, input, linear layer in between, then the output. Now, The linear layer, which is next, is built or is defined using nn. Remember, you import torch.nn as nn for convenience. You just import this as nn instead of having to type torch.nn every time. You just import it as nn. That's why you have this imported this way for convenience anyway. So input tensor, which we've seen earlier, you convert your data point into a tensor, and now you initialize a linear layer. In this case, to do this, you just call the linear method on nn. So nn dot linear layer input feature is equals to 3. That's it. Yes, in this case, you can see we have 3 data points. You can see it here. There are 3 data points here. Then the desired output features, the desired output features we want. So in this case, it's 2. All right. Then okay. Now to see to be able to receive the output so far you want after initializing a linear layer, what do you do next? You pass the input tensor to the linear layer, which you can see here. The input tensor you converted earlier, you pass it to this linear layer model you initialize in order to it to go on with the prediction or whatever task it has at hand, which gives you the output, which is the final result in this case. All right, so you can see an example output. Remember, it's 2 pictures we initialize. So if you wanted 3, you can choose to put 3, depending on the task you have to solve, the given goal. And in this case, you can see the result, and our result is still in a tensor form. You can see it here. It's in a tensor format. So you can see that basically deep learning or PyTorch in this case have been working with just tensor forms or formats of this data. So that's why it's one of the building blocks as we mentioned earlier. All right, so you can see 2 data points or results have been included here because we said we wanted just 2, right? In the given goal we have at hand. So this is the final result. But there is more. There is more to the properties or characteristics of deep learning, and yet another one of the some of the characteristics are weights and biases, and this is something that is basic. Like I even mentioned that in the last class that weight and bias biases are one of the basic components or concepts we should be well aware of in machine learning. And let me go to who can tell us what they remember about weights? Because it's very basic. It's a must know in order to implement the likes of supervised learning and
Okay.
unsupervised.
Hello, sir.
All right, go on,
Okay,
David.
yeah. So weights are like the coefficients. So like for coefficients of, for example, like every input have their contribution to the output. So maybe like a particular feature is contributing more than the other. So those weights are like the features. So yeah, so like the coefficients of the input. So maybe you have like maybe 0.915 will have more weights. Like if a feature is having maybe
Mm,
0.915, it would have more weights than one with maybe 0.015. So the one with 0.915 is a major
okay.
contributor to the output than the one of 0.015.
Mm, yeah, that's good. That's good. Uh, Everyone appreciate David. Just appreciate him using that. Yeah, thank you everyone. So I believe that's clear. Maybe for some of us that might have forgotten what weights are or which weight is. Okay. Does anyone need clarity? You can just raise your hand because It's a very important concept. I guess it's clear for everyone. Then biases. Akachi, you want to try? Or Zainab, you want to try? Who wants to try and remember what bias is?
Hello?
Okay, okay. I can hear you, Zainab. Please go on. You can go on, Zainab.
Okay, bias is like taking side or differentiating one group over the another one.
Oh, sorry, go over that again. I didn't hear you clearly.
Okay, I say bias is like taking side
Mm.
or differentiating one group over the another.
Okay, okay, okay. I get you now. I get you now. Okay, okay, okay. Yes, 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 yes. Yes, yes. That's true. That's true. But to touch more technically, to go more technical on the term bias. Who has something else to add? Does anyone have anything to add on bias? For the sake of machine learning technicality. Hikma, you want to give us something? Okay, Labibat. Labibat, go ahead.
Alright. When we talk about bias in machine learning, it
Mhm.
usually occurs when the algorithm produces produces skewed results due to flawed data, and
Okay.
it sometimes, most of the time, leads to unfair
Mm,
or inaccurate outcome.
mm, mm. That's true. That's true. That's true. All right. Anyone else? Okay. Hikma, nothing for us.
So the biases are errors that causes that leads to overfitting or that leads to overfitting when we create
Mm,
our model. So there are errors that leads to us having um looking for the word. There are errors, there are sure errors that leads to overfitting of the model. They lead to us they give they sometimes give more weight to features that don't that not necessarily have those weights, so there are errors in the data.
mm. Okay. That's good. That's good. Good. Great to see everyone and at least remember one or two meaning. Yeah. So Zainab was correct. Labibat was correct, as well as Hikman. And as Zainab summarized it, is when the machine gives more preference to certain group or data points than the others. In summary, then technically it involves, yeah, it's basically refers to it's an error anyway, and in most cases it from skewed data. These are just basic concepts we should have remembered. We should have at the back of our mind as machine learning engineers and AI as well. So now, in this case, um, you can see this diagram now. In order to come up with the inputs now, in order for the deep learning model to come up with an output, with the final result, behind the scenes, weights and biases is constantly calculated. As you can see here, constantly calculated. So you can see how important these concepts are. Now, to see the weight of the linear deep learning model, like the one we initialized earlier on the slides, you can check this gear dot weight, calling dot weight attributes on linear layer, and you see here, this is the weight that's reflecting the importance of each features you have. You can see the weight that was assigned to this feature, to this one, to the next one, to the next one, and so on. You understand? Then bias, the same way can be assessed via just calling the bias on the model, which is linearly bias. You can now see the quantification of the bias present in the model. Okay. Now, a fully connected network is action. Now, let's see for this linear layer situation, let's say maybe, okay, it's more comprehensive here. So you are trying to carry out a task using deep learning on if it will rain or it's cloudy. So they're training this model this way. So you have features now, input features, and in this picture, one of the features there is the temperature, another is humidity, and another is the wind. Things about the wind. All these features now to help identify, given the data points and these characteristics or parameters, that will it rain or will it be cloudy? Now, but in this case now, to explain with further, you might tend to agree that humidity we have by default, we have more significant weight than the others. Do we agree? Does anyone agree with that? Thumbs up if you agree. Then thumbs down if you disagree. Okay? Everyone agrees. So that's great. Everyone agrees. Good. Mr. Ibrahim, do you agree? I didn't see your thumb up. Since you disagree with us, or you're not on the meet with us, okay, that's fine. That's fine. Yeah, and this is just because humidity, when it comes to if the weather or rain or cloud, humidity is a very important feature. Yes, it is because in fact it's only humidity in some cases you can be able to tell not 100% or just tell the next step of the weather. You understand? So why bias here? We account for the baseline information, like it captures when you first input the data, because for a complex deep learning model, there's something to know. For a complex deep learning model, these features, this weight and bias sometimes tend to be modified. Yes, it tends to be modified. So bias, which is the first bias recorded, we take note of the baseline information at the start of the training. Then now, let's talk about hidden layers parameters. You know, we've been talking about hidden layers, hidden layers, hidden layers. So how do we practically implement hidden layers? How can this be done? So you can implement hidden layers by stacking. There's something called stacking. So you stack layers using this method available on PyTorch, which is nn.Sequential. So you initialize a model like after having a tensor form of your input data. You initialize nn.Sequential. Now it's in your power or ability to create as much deeper layers you wish to do via stacking. And you can see three so far here. The first one, nn.linear, n features is passing, comma 8. We'll get to explain all this very soon. So you can just see the stacking here. If you remember earlier, the simple linear layer we did was just nn.linear layer, right? Does anyone remember? Sometime earlier, you can see it was basic, but now we are starting to go more complex or more sophisticated. So in this case, you have three of these linear layers. Now, the first parameter it takes in here is the input data, which in this case is called n features. It is initialized as n features. So just imagine this is n features equals to data points we have, which is in tensor format. Of course, we already know that by now. Then 8. What this 8 means is the first layer, layer 1 here, the first layer is taking in the data points that we have, which is the input data, and outputting 8 is outputting 8 values in this case. So the next layer does what? Takes in the previous output from the previous layer, which is repeat 1 here, and it works on it, does the necessary processing, and outputs 4 for the next one. So you can see the interconnection between them. You can see the interconnection between them. And finally, the final output you want, which is maybe 2 in this case. So you can choose to say, okay, 2. Well, let's say in this case, you're trying to carry out this prediction or this learning in this case now. And the final output you want is if it will rain or to be cloudy, right? This is a kind of, yes, it's classification problem. So it takes in this, passes through as much hidden layers you initialize, and finally, it has to output the desired number or targets that you want in this case. Now you can see input in this case, as we described here, is passed through linear layers. And these layers within, the layers within this nn-Sequential, like we talked earlier, are the hidden layers in this situation. You can see them here. All right. So, okay. I think they are explaining now. Yes, yeah, we tend to explain now that the n features here refers to the number of input features. The n classes refers to the number of output classes. Yes, which we just talked about. Now, adding layers. Like I mentioned earlier, if you remember, I just kept mentioning that you also have the ability to add as much layers as you want. You can grow these layers to as much as you want, depending on what will help achieve the goal you have at hand. So you can see with a pictorial diagram here, you can see the layers here are not as much as it is on the second slide, because here now it has been a lot more hidden layers have been added to the system in this case. Then you have an output. So you can see another situation of stacking layers using nn.Sequential. You can see the first linear here takes in 10 data points and puts 5 results. And you can see everything in between. Now, if you observe, there is still interconnectedness or interconnection between them. You can see the first layer has put what? 18. Then the next layer tends to work with the previous output number from the previous layer. You can see it here. You can see the interconnection between them now. All right, this is another further explanation. Starts with an input of 10, it takes in 10 features, and outputs 18, that is for the first layer, takes in 10 features, outputs 18. The next layer takes in that 18, outputs 20, and the next takes in 20 and outputs 5 finally. So that's just basically the explanation we are making here. Yeah, that's it. Then layers are made up of neurons. Yeah, we already established this part, and they are fully connected. In the diagram, you can see the connection between them. Then, practically, this is the interconnection we are talking about. How the next input for the next layer matches with the previous output for the previous layer. You can see it's fully connected when each neuron links all neurons in the previous layer. Okay. All right. So a neuron is a linear layer. Okay. Which you can see. Remember earlier how we created the linear layer. So each neuron represents a linear layer in a deep learning model. I just hope I'm not sounding technical so far. Does anyone have any question? Please, I encourage questions so that we understand better. Then I assume everyone is following through. Please, thumbs up if you understand so far. Okay, Ibrahim, Zainab, Hikma, Labibat, all right. That's fine, that's fine. Chemistry, it's been great so far. All right. So all these are just safe to understand. Like when you get on, I just I believe next for the next breakout session I should be the one taking on. So I'll just look because I try to also check for some projects on deep learning on data can. Maybe I'll just look better and I should be able to find something so that we can practically implement the deep learning. Maybe something very big. Okay. Then all right, let's go forward. Okay. Okay. So now a linear layer in a neuron. Okay, a neuron in a linear layer. Now this linear layer, for instance, now this neuron specifically in this layer tends to perform a linear operation using all the neurons from the previous layer. Wait, true. Yet it's the same thing here that we talked about. The internal connection we talked about earlier. That's what is being spoken here or talked about. Yes. Okay, now you can see now they're explaining how bias comes in play. You can see that apart from the neuron, in this case, is taking all, yes, the layer is taking the all neurons from the previous layer to perform the linear operation. There's also an arithmetic operation going on. Now, what is also passed on or considered is end pictures from the input is now added to the bias. You can see because it must definitely consider the bias in the data points here. Understand? In order this bias will help you understand the necessary adjustments you need to make in order to give more accuracy or so. And also to be able to track how evaluation will go about. I think we'll be able to cover evaluation. And you see how this, we also see how we can leverage on the weights and bias of a deep learning output, like after first training and doing evaluation, how you can be able to adjust that manually in order to correct the mistakes from any prediction or any output. So parameters and model capacity. Now, more hidden layers gives birth to more parameters here too, which gives birth to more, which also equates to higher model capacity. Yes, yes. If you remember earlier, we said the more hidden layers, the more deeper the model is. So that's what we've been explaining here. The higher the capacity of the model. Okay. Okay. So, okay, yeah, this is a further explanation on the manual calculations that goes on So using this model here that is initialized on the left-hand side of the slide, using nn.Sequential, you can see the first layer takes in 8 features and outputs what 4, right? Which is 4 neurons. And the second layer takes in the previous 4 neurons from the last layer to output what 2 as a final result. But now the calculation here is done by the first layer. The first layer now has 4. You can see 4 here. 4 neurons, and each, okay, 4 neurons. Now for these 4 neurons, each neuron has 8 plus 1 parameter. That's the 8 from the previous, sorry, from the input feature. That 8 plus 1 gives you 9, right? Then 9 is multiplied by 4 to get the total parameter from the previous layer, which is 36 parameters. Again, we'll get to talk more about this during evaluation. Just hope we have the time today. We've spent a lot of time already. Okay, so this is the same about the calculation. We talked more about this during evaluation. Okay, parameters and capacity. Okay, yeah. This is just using PyTorch to calculate the. You can see the end result here. The total learnable parameters here is 46. Now PyTorch have this very simple way instead of manually. It has this simple way of calculating the learnable parameter. Okay, hopefully we have the time to talk on evaluation. We'll get to talk about it. Hope to close the class by 7, 7:02. Because have 12 minutes. Have 12 minutes. Okay. Yeah. Balancing. All right. Now this is the very important. This is a very important factor to have in mind, because in as much as you have the ability to grow the hidden layers, yes, to grow the hidden layers you have in your deep learning model, you should also be careful about complexity of the model and the efficiency. Let me see if anyone can try. Who can who can explain why we need to balance between complexity and efficiency in the deep learning model? Anyone wants to try? Like just um you can apply the school of thoughts from the likes of the supervised learning models. Remember, we say the model should not be too complex. Why did we always talk about complexity? That's a guy to help answer the question. Does anyone want to try? Everyone is quiet. All right, please go ahead.
Okay, so I'm not sure, but I think if a model is like too complex, it might learn, the noise, the deep learning model might actually maybe learn too much and doesn't get to see things from the bigger picture. It just, it picks up the noise, picks up everything, and it might not be very efficient. The output that you have might not be very, like, your output, the model might not be very efficient if it's too complex. But if it's too efficient, if it's on the other hand, if it's efficient, you want to make it look like, okay, it's moderately complex and it's moderately efficient. If it's too efficient and maybe
Mm.
it gives you, it might not be very complex. So I don't know if that captures it enough.
Okay, yeah, you did great. Thank you. Yeah, that's one way to look at it. Hi, Labibat. Please go on.
I didn't actually updated it. I just want to like
Yeah,
okay.
Labibat, since your volume is a little bit low,
Alright. Can you hear me?
it's
Can you hear me now?
getting a little bit better. Just a little improvement.
Can you hear me?
Uh,
So can you hear me now?
Switching between good and bad. All right, it's great now. It's great. Go on.
Can you hear me now, sir?
Yes, I can hear you, Labibat. Please go on.
It's just like basically trying to manage the bias and variance and trade-off and trying to prevent overfitting and underfitting.
Mm, mm, true, true, true. That's true. That's true. Yeah, that's another great way to look at it. And you just touched on, I like the fact that you just touched on some foundational concept, bias and variance. Can you also just remind everyone again what you might have remember, what you remember from bias and variance trade-off, that concept?
Okay. First of all, I think I should just like should I okay. Basically, when we're talking of bias and variance trade-off is
Mm,
something that relates to underfitting and overfitting. And we know before that
okay.
underfitting is like when the algorithm trains more.
Mm-hmm.
Like how should I explain it? I mean, the algorithm trains more on the training data set and it's not able to like generate on the
Okay.
new data set. That's the set.
Mm.
Then overfitting is like okay, we train it. I think I'm already come sir.
I think you're mixing up things, right?
Yeah, I'm mixing up something. Overfitting is when it
Okay.
trains more on the training
Okay.
sets, like it's practice more on the training sets and it's not able to generate on
Mm.
the test sets. Then underfitting is when it's able to generate on the test sets, but not on the training sets.
Okay. Okay.
Then the
Thank you for
bias
trying.
variance trade-off is like relationship between
Okay.
model's complexity, the accuracy of its prediction, and how well it can make predictions on previously unseen
Mm.
data.
Mm. 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 Great. Thank you for trying. Thank you for trying.
Okay.
Yeah. Hikma, you have you want to support?
So,
Yeah.
so
Bias
I
variance
think
trade-off.
okay when we talk about it, I think the underfitting is when the model does not perform well on both the training and the test set, and then this could be due to complexity. When
Mm-hmm.
the data points are too complex. Then for overfitting is when it learns the training set too well that is not able to perform well on the test sets. So this could be due to biases, then it could be due to the fact that the model is too simple for it, so it trains too well on it, and then when it's on the test sets it performs poorly.
Mm. Okay. That was a nice one. Anyone else? Anyone? Okay. All right. So far, all right, Ibrahim, please got something.
My contribution to the correction to what she just said.
Okay, correction, right?
You mix up um how um the,
I can't hear you clearly since your volume is a little bit low.
I think she mixed up. Can you hear me now?
Okay. Oh yeah, it's great.
I think she mixed up how the the model the model
Okay.
being two, which is
Okay.
having high leads to over underfitting, and she said it's overfitting. And then
Okay. So now,
when the
okay. So basically, you're saying high bias is what leads to underfitting, right? Okay.
and
Go on,
then
please.
high variance, which means
Mm,
the that is too complex, leads to overfitting.
mm, mm,
Yeah,
sure.
catching.
Sure. That's true. All right. So yeah, that's a good correction. Yes, it's a good correction. And I see. I observed that you might have forgotten most of these things. Please, it's very, very, very basic. Like these are things we should even learn every day. We should revise every day. The concept of underfitting, overfitting, um, bias, and variance trade-off. These are very important features. So please, let's just go back to them later on. So now there's something else we talked about during the start of the class. We're almost coming to an end again. And I want us to go back to it and now ponder like, first, let me throw in this question. Give me a thumbs down if you disagree, or in terms of if you agree. Can I train a deep learning model with a small data set? Mhm. Only two people. So I I see, okay, Hikma agree that. After you agree that I can train with a small data set, deep learning. Labibat disagrees. Zainab, you agree? Hi, Zainab. You disagree as well. Please. Now, the question is why? Why can't we use a small data set to train a deep learning model? That's the next question. Why? Why are they making that rule? Yeah, anyone can tell us why we are afraid, why should be concerned to use small data sets in deep learning models? Zainab, you want to try? Just try. Try and try something. Hi, Zainab. All right, Labibat, please.
Okay. I'm actually not sure about this, but like just if we are using a small data set for a deep learning model, it
Okay.
might algorithm might undergo overfitting because the data set
Mm,
is too small and the
mm,
algorithm like the model can like perform well on a limited training data sets, but poorly on new data.
mm, mm. Please. Hi, Didi. Please, what do you have for us?
Oh yeah, I was going to say the same thing too, because
Mm,
the deep learning model does not generalize over like large amounts of data points, and so it's going to overfit data. That's why it's not very reliable.
okay. Okay, true. Okay. All right. You guys are very, very much correct. Very, very much. Because, in fact, when you use deep learning models, one of the default situations you should be careful of is situation of overfitting, because deep learning model could be so deep in terms of building layers to achieve this goal. So I remember this project I volunteered for, I think that was around early this year or last week. So the project was about um the project was on translation, translating English to local words, yes, and back and forth. So just imagine like a language like Yoruba. So the model was supposed to take in okay, be able to identify Yoruba words and be able to understand and put the correct English meaning of this Yoruba word and vice versa. But now there was a problem with the model that was used. The model was overfitting because data was in lack. Yeah. And well, that project, I don't know so far, but gathering that kind of data is a barrier anyway. So that's just what I wanted to touch on. That the practical situation I witnessed, the model was just too overfitted. Start going into these new concept, you ask it new questions, it just dumbfounded. It just feels woefully flat. Bitch, are you trying to say something?
Oh no.
Fine. Okay. All right. Does anyone have any question? Because 7:33 and that's that's all for the class today. Next week we are supposed to do some practical implementation. Hi everyone. Any question?
Okay, so it's not about the class. So I understood like introductory knowledge of what we've done today, but while like I think some classes that I might have missed, have we done anything like serious that I might have
Mm.
missed? Because I haven't gone back to watch some of the like anything serious like projects or assignments, anything like that. Because I'm afraid that I might have missed out on some things.
Um, well, I'll reach out to the other instructors. We are shuffling between facilitators for the class. So I'll just, well, I guess so. I guess a lot might have been done, such as the assignments, especially. Right? Oh, Hikma, last time we were complaining
We're
about
complaining
the
about
assignment. Can
the
you confirm?
Can you
Oh, I think apart from the assignment they assigned to us on data
Mm,
camp, the last one that was about predictive agriculture.
mm.
I've not seen any other assignment. I also missed a class and I've
Mm.
not been able to watch a class from Flowers, but I don't think there was assignment he gave apart from
Yes,
that.
because
just
I
because
remember
I remember
Mr. Fawaz touched
Mr.
on
Fawaz touched on
natural language
natural
processing.
language processing
I remember
and
correctly.
human studies.
So I think that
So
is
I think
something
that's something
for what I remember
for
now.
what I remember now.
Yes, sir. And then I've noticed that we've stopped. It's been long we gotten any assignment on data camp. After that predictive, we've not been assigned any course to take. I think the last course we assigned was on cluster analysis.
Hmm. I think remember you talked about this earlier. But this could you do the previous one, which is the clock analysis you just mentioned, the last assignment before the method?
Sir?
No, I mean Deji.
Okay.
Since his network is bad. Mm. I tried to reach out from the last time you complained about this Hikma. I tried to reach out to the
Sir?
lead to handle that. Maybe I'll just follow up again and let's see if there's a technical issue around. We'll
Alright,
definitely
thank
try
you.
it.
Thank you, sir.
Yeah, you're welcome. Any other question from anyone? No question. No question. I feel like asking some questions. But meanwhile, let me get the attendance on for today. I'm still waiting in case there's a question while I get the attendance. All right, I just dropped the link for the attendance form. Let's kindly fill. So that means everyone could understand everything on deep learning so far. That's great. That's great. That's great. So next week we get doing. And in fact, I would encourage us that you shouldn't even wait for next week for us to do this together. You can just on your own go on Carry check, look deeper in data camp. You find facts on deep learning in this plan so that you can familiarize yourself with it. Just the same if you ask me. Can anyone else click on the link? Who is complaining? Okay, because we can. How about the rest? Can you click on the link?
Mm. Hello, sir. I can also I can't click on the link also.
And let's see how we can copy and paste. Try the next one. Is it better now? Mm. Still the same thing. Um, okay. I think that might be one of the features from who do you say? I do want to do it to prevent link sharing. I don't know, just thinking. Let me see how it's done. Let's try one more time. Yeah, so I think it's the difference with attending. Still not working, right? For the latest one, I just sensing. All right. So, no problem. I need to take again. All right. All right. So, not to worry anyway. I'm just taking the appointment. Okay. What's for Zainab? Mm. Didi, can you unmute your mic and describe how the link comes in at your own end?
Okay, it comes at text because my laptop is dead, so I cannot click on it and I cannot copy it. So maybe if you send it to the Discord channel, that would be better. Or if that's on
If I
out.
send if I check Discord channel, people who are not in the class with you,
Okay, yeah, true. That's true.
that's the problem.
Okay, that's true.
I've already taken attendance anyway, but I'm just trying to figure out.
Okay. Yeah, that's the better
It
option.
might
Thank
be
you so
like a
much.
consistent challenge you have about things.
Okay.
Trying to figure out how you can solve it. But do you see the complete um, endpoints, URL endpoints, HTTPS, ending with link?
Oh yeah, I see it, but it's not. It's only appearing as text. There's no underline that will make me click on it directly. And I think sometimes I used to click on Google Meet messages that have links on them, but this one is just appearing as text.
That's all. So, just see how we can figure out that for the next class. So, yeah, thank you, Deji. We've come to the end of the class today, but I'm still open to question. I don't know how many questions, even if it's not about teaching, like in matters regarding data camp, your learning, your career journey in AI and machine learning. Let's discuss for the few 5 minutes or less that we have. Okay. All right. Okay. Yeah, and that's fine.
Okay. I don't
Like,
have any questions for now, but I'll keep in touch. I think you left your number one time, so I still have your number, and I added you as a connection on LinkedIn, so I can always reach out to you if I have any problems, any
okay.
questions.
Okay, okay, okay. All right, no problem. No problem. That's fine. There is a suggestion from Ibrahim. I think Emmanuel did this last Friday, last Saturday, important and copy from the paper. I think Emmanuel is pretty long. Okay, no problem. Okay, so last week there's something I talked about before we leave. There's something I talked about in terms of career growth, and it's very important, very important. I will just summarize. Um, oh no, why no? So Emmanuel, I'm trying to drop my number, but my keyboard is misbehaving. Um, Okay, so Emmanuel, just type on the chat in case some other people need my number. Just type my keyboard is misbehaving. 090-696-25266. That's it. Just send on the chat so that in case someone else needs my contact. 090. Yes. If anyone got it, you can just use on the chat. 090-696-25266. Anyone got that? You can just use on the chat to order. All right, hold on. That's it. Yeah, hold on. Great. So, yes, I wanted to talk about the use of LinkedIn. I talked about this more with you last week, but let me see how far we can go. So it's not just about learning, it's about building online and connecting. So this learning phase is one of the most interesting, in fact, one of the most um how do I put it? It's basically the point where you need to even connect more. You should start building connections, start building in public. For instance, now you're attending to this class debate session, you can have an active social media where you just come online, you share what you've learned, you understand. You just post, you get that today I learned about deep learning. These are the few concepts I learned from deep learning. Yeah, AI Community Africa affiliated with data farm, or let's say tomorrow now Monday, or sorry, tomorrow Sunday, you do the project. Let's say on linear regression, you learn a new concept. You get That's where you come online and just share this stuff. It will likely be one of the um pivoting steps in your career entirely, especially for people who hope to use machine learning as a career, or who see machine learning as a long-term career in terms of getting jobs, that's working with clients for jobs. So yeah, in summary, that's just it. And last week, Emmanuel, I think Emmanuel, yes, if I remember correctly, Emmanuel tried to ask if there are other alternatives to LinkedIn, but I always recommend LinkedIn. Why? LinkedIn is a specialized platform for this case. You get, you can do this on Twitter. People are winning on Twitter in terms of building in public, actually. Building a brand, like branding themselves. Yeah, that's the correct way to put it. Using themselves as a brand on this platform. But LinkedIn tends to be more specialized for this use case. You understand? So yeah, that's it. Because opportunities like jobs, recommendations can come in. People and just you don't know who might be monitoring your feed. And they see that okay, oh, you've been consistent in this, you're learning in this particular career. And when they feel there's a need for your service, they can just reach out. And some people they might not even be any of your followers, or they don't react, they don't comment on your post or anything. That's why it's it's another reminder to don't look at impressions or metrics or engagement on your post. No, forget about all those. Even if you post and nobody likes your post for a whole 1 week, forget about that. The point there is, or the question is, um are you building a brand in your career that let's say, because sometimes, oh, these days I see um comments from other engineers. They feel like, oh, this job, at the course of this job, you ask for my LinkedIn. Like, why are they looking for your LinkedIn? Sometimes it's LinkedIn or it's Twitter. They want to go see if the interactions you have on your feed is justifies that uh, what you present. Like, do they justify what you present? You don't want to say, okay, you say you're in AI machine learning now. When you go to your page, we are seeing something different, something far different, or maybe it's empty. You're not active on social media. These are some of the different, because some of these brands, they see this as trust. They see that, okay, yeah, it's your proactiveness in this field which you're showcasing online. You can trust that to a point you represent what you claim. You understand? That's outside the opportunities that can come in. Yeah, like recruiters reaching out to you and the rest. Anyway, there's more to this discussion, but I just wanted to put this at the back of my mind. But please encourage yourself to start building online while learning as well. Okay. Ibrahim posted the link again. I don't know if anyone could click on it, but it's fine anyway. I was able to take attendance in a different place. So yeah, that's all from me, everyone. Good night and have a good Sunday ahead. See you next week.